Okay, now that we have an understanding of the idea of the limit of a function, now we're going to talk about a method of finding a limit by direct substitution. So if you have the limit of f of x as x approaches c, it's also equivalent to the function evaluated at c. Okay, most oftentimes when we're given a limit, we always try direct substitution first because it's the easiest method, and if it works, we're really happy. And if not, we're going to talk about some other things that we're going to do when it's not the case. But so these next few examples, we're going to practice using direct substitution. Okay, like I said, we're going to do some examples here. Based off of our limit of f of x as x approaches c, we can get that value by evaluating f at c. So what we want to do is we want to take our function f of x, so we have 3x plus 2, that's our f of x function, and evaluate it when x is equal to c. What is our particular c value in the given? -3, good. So plug in -3 and it's a direct substitution. So that's just going to give us -9 plus 2, which is -7. So the limit of the function, if we have a graph, we can do what we did a minute ago, and we can look at it from the left, look at it from the right, and to determine what it approaches. But when we have an algebraic situation like this, direct substitutions are our favorite. All right, the next one. Okay, so take a minute to jot that one down and then try it. Okay, we're plugging in 1 everywhere that there is an x. 1 squared is 1, but I have this negative out front, so -1 plus 1 is just going to give us 0. Good. All right, I'm going to jot a couple, like 2 or 3 more down. I want you to write them down, pause it, and then try them on your own. Okay, so I added 3 more examples. If you will, just pause the video, jot down these examples, and try direct substitution by evaluating the function at c, and then you can check your answers. Okay, some pretty basic algebra here. We just get -1, -2, and 3. The limit of a function, when it doesn't have a variable in there, when it's a constant, it's just going to be that constant. Okay, we're evaluating the limit, so we have the limit as x approaches -3, and our functions are a little bit more complex, but let's attempt direct substitution. Okay, so our attempt of direct substitution sometimes gives us a meaningless fraction in the form of, what do we get here? 0 over 0, and that has an expression, and it's called indeterminate form. So we attempt direct substitution, but if we find ourselves in indeterminate form, we cannot use that to determine the limit. We can rewrite the fraction so that we can factor this out and see if there's something that cancels. That's one of the things that we're going to try to do next. So what we want to do is see if we factor the numerator, factor the denominator, and see if we can cancel like factors. So what multiplies to give us -6, adds to give us +1, factoring. I can rewrite this as the limit as x approaches -3. The numerator would be what? X plus 3, x minus 2. Multiplies to give us -6, but when I add these, I get +1. That works. Over x plus 3. So what cancels here? X plus 3. So we can rewrite this as the limit as x approaches -3 of the remaining factor, and then we could try direct substitution again. So this would just be what, -3 minus 2 is equal to -5. Okay, so in the case that we typically always like to try direct substitution first, if you find yourself at 0 over 0, it's indeterminate form, one of the things we try to do is to factor and cancel like factors. So let's try another one of those. Okay, so if you want to jot this one down, pause it, attempt direct substitution first. If you get 0 over 0, then factor the numerator, factor the denominator, cancel factors, and then try direct substitution again. Okay, so direct substitution, I ended up with 0 over 0, got indeterminate form. Then I factored out a -3 here, it left me with x plus 2. In the denominator, I factored out an x squared term, left me with x plus 2. That's what we're hoping for. We're hoping some factors cancel. Then I rewrite my limit as x approaches -2 of -3 over x squared. Try direct substitution, and in this case you should have simplified that to -3/4. Okay, so we have number 8, limit of this function, of this f of x as x approaches 1. This is a real simple direct substitution to test. 1 minus 1 is 0. 1 to the 4th power minus 1. We're going to get 0 over 0. So my note to my side, off to the side, is going to be that. So we want to factor the numerator, factor the denominator. This is difference of cubes, so you might want to go look that formula up, and then this is difference of perfect squares. Just in case it's been a while, for the numerator, your difference of cubes formula, and in that particular case, what's A? X, and what's B? 1. A is what's cubed here is A. What number cubed gives you 1 is B. So then you would plug these values in, and that would just be so A minus B, A squared plus 1 times B, so plus X plus 1. Okay, that's using our difference square. And then we have difference of perfect square, which is, quick reminder on difference of squares, A plus B, A minus B, but in this case, what's A? X squared, right? So then we would finish with, we would have x squared plus 1, x squared minus 1. Okay, but what about x squared minus 1? It's also difference of squares again, so let's not in this same step, but let's show another step where we're going to factor this. So what would this be factored into? X plus 1, x minus 1. So let's do that next. Okay, so then after we've factored this out, we're now working with this. And we look to see if any factors cancel, and we can see that x minus 1 factor, x minus 1 factor. And now we want to attempt direct substitution with what we have left and see if we get a value. So that would be 1 squared plus 1 plus 1. Let's simplify that. What do we get? 1 plus 1, we get 3. And what about in the denominator? 1 squared is just 1 plus 1. 2, we get 4 right there. 3/4. Okay, so it might be a little bit extensive. This one, we particularly did this one just to remind you of your difference of cubes formula and also your difference of squares, perfect squares. But the idea is attempt direct substitution. If you find yourself in indeterminate form, you want to factor numerator, denominator, look for a term that cancels, and then try direct substitution again.